Yeah, so I have no idea if this talk is going to take 25 minutes, but we'll see. Okay, so hello. As introduced, my name is Darragh Enright. I'm a web developer here in Cork. I'm a LAMP guy, so I mostly use PHP and a bit of Python as well. So that's kind of basically what I do. My history is I kind of fell into programming years ago because I was originally into music tech. And this is why this kind of subject kind of interests me, because it's kind of a confluence of, you know, what I used to do and what I do now. Yeah, let's soldier on. Let's talk about web audio. And this is the obligatory Twitter. It's like probably won't find much there, but anyway. So I figured the best thing to do would be to talk about computer music first of all, because even though it's not strictly, it's not really strictly related to, you know, HTML5 obviously, but it's good to get a bit of context. I think you'd be surprised at how old computer music is basically. So I have a very, very incomplete timeline, very incomplete. So we'll start at 1950, and you'll see the world's worst acronym there, CSIRAC. Is Australia's first digital computer, and it is also the first computer ever to be used to create music. Now, apparently there is no record of this, but apparently it's also true or whatever. 1951, the Ferranti Mark I at the University of Manchester is used to create the oldest recorded computer music, including God Save the King and Blah Blah Black Sheep. So that is the first recorded music, just for reference. So that gives you an idea of like the state of tech back then. 1957, Max Matthews is a very famous guy in computer music, writes a software called Music at Bell Labs. And it's basically the first of a long line of kind of audio synthesis programs that are very, very influential over the years. 1961, Max Matthews then is also responsible for getting the first computer to sing a song. And you might find this. You can all hear that, yeah? Yeah. You get the picture. So if you think that sounds familiar, well, you've all seen 2001. So Arthur C. Clarke went to visit Bell Labs basically in the 60s, and he was basically played the song or whatever, and he encouraged Stanley Kubrick then to implement it into his implement, to use it in his use it in 2001: A Space Odyssey. So it's kind of a lot more sinister in the movie, but it's pretty interesting. The 70s, we're skipping forward a bit faster now, development of FM synthesis and lots of other stuff that I'm not going to mention basically. The reason why I mention FM is because it becomes very important, and we're going to do a bit of FM in a while. So we'll brush over the 70s. I like to think of the 70s as the era of these kind of beasts basically, because I'm a big fan of analog synthesizers and whatnot. And the 70s was definitely the heyday of all that kind of gear or whatever. Interestingly enough, a lot of this is an ARP 2600, which is an analog machine, but it's semi-modular. And that's also interesting because the Web Audio API is kind of a modular idea. So we'll look at that. Up to the 80s, Commodore 64, we were starting to see, you know, games and music in the home. 1983, you have MIDI, the Musical Instrument Digital Interface Spec, which is a protocol basically for musical instruments to talk to each other in a kind of a uniform way or whatever. 1983 was also the year that FM kind of became a big thing in audio synthesis, digital synthesis, because a synthesizer by Yamaha called the DX7 was released that year. and that basically killed analog synthesizers dead in the water, and there was like a new era of digital synthesis. So interesting stuff. 1984, a guy called Barry Vercoe creates C-Sound. I don't know if anyone has ever used this, but it's a very kind of cryptic way of making music, basically. It's a DSL for creating kind of music or whatever. It's very powerful, but it's very low level. It's basically, you have an instrument file and an orchestra file, and I mean, this is a kind of a straightforward example. Basically, you have a sound module called an oscillator. You define some kind of symbols basically as inputs or whatever. So you can think of that like a function or whatever. Oscillator goes out to A1, that's an output, and then A1 is sent to the basically the main output. So that's your instrument, and then you painstakingly define your music note by note in the orchestra file. As you can see here, you define the start time, the duration, and you can see where these values then are fed back into the oscillator. So it's powerful stuff, and you'll spend, I did a lot of this in college, and you know, you spend weeks and weeks and weeks just staring into a kind of a text editor, which would, you know, basically set me up for a lifetime of doing that now as a programmer. The reason particularly why I put this here is because I think this was my first kind of introduction to programming and music or whatever, so I thought that was interesting. I like Atari STs, so I just added that there. Another music kind of popular machine for music. Commodore Amiga as well. You had the birth of trackers if you ever wanted to make music in hexadecimal. This was like your ultimate tool, basically. 89, you start to see MIDI sequencers starting to kind of really take hold and become something kind of familiar to what we see today. I'm sure a lot of you who probably make digital music are kind of familiar with that. And in the 90s, so by now there's tons of software in the web or whatever. Some of it's pretty bad, but like you have a lot of freeware, shareware kind of stuff. So I'm going to show you a very quick example of some of the ones that I used to use. There was this really basic one called Stomper Ultra, which was for making drum sounds. And what you do is you create an oscillator, and then you click, you know, kind of render or whatever, and it will go doom. And you go, okay, that sounds pretty good. And then you create another one, you layer them up. So it wasn't really a real-time tool, but and it was very basic, but it was pretty cool back then. So, you know, you make these kind of totally synthetic drum sounds, save them to WAV files, and then you load them into this program called Hammerhead, which was just like a kind of a digital emulation of, I suppose, kind of like an old school kind of tap step kind of a drum machine, like the TR-808 or 909, if anyone's into all that old gear, you know what I'm talking about. And then a little bit later, there was Vaz, which was kind of on my computer approaching real time. I think it was like 200 or 300 millisecond latency, basically. But you could kind of do real-time synthesis in this, and this was kind of showing the direction in that computers were getting powerful enough to make real-time music. And then, of course, we had this, which is very famous. It's kind of a modeling of like some very old Roland gear, and this was kind of pretty huge when it came out. So, etc. So. The reason why I'm saying this is because at the present day, we're at this kind of situation where computer-based recording and synthesis is incredibly powerful. You have, you know, any bog standard computer now is a complete studio, and, you know, minus the mics and whatever else you want to add or whatever. So we're kind of at a point where, you know, computers can do so much. But what does this have to do with HTML5? Not much, because this software we're looking at so far is obviously written in kind of like, you know, highly performant languages or whatever. Is it okay to say performant, by the way? I know some people don't think that's a real word, but anyway. Anyway, basically, that's fine or whatever. You kind of think, okay, if you want to write software, basically for music, you know, you got to learn C++ or something like that. But on May the 23rd, 2012, Google released this. I'm not sure if anyone, a lot of people probably remember this, but the 78th posthumous birthday of Robert Moog. He preferred to call it Moog, not Moog, apparently. And it was playable, recordable mini Moog. You could actually record like 4 tracks onto this, and you could play it with your keyboard. It was pretty awesome. So that was fine, but I remember reading about it, and it basically says, much like the musical machines Bob Moog created, this doodle was synthesized from a number of smaller components to form a unique instrument. When experienced with Google Chrome, sound is generated natively using the Web Audio API. So I was like, this is interesting. So this was my question, and I kind of looked into it, and it did. Now, maybe some of you were familiar with it. I know when HTML5 came out, there was tons of stuff, like, you know, there was WebGL and all this other kind of stuff that was really, you know, totally underdeveloped and just kind of really a working draft. But it was in there, so it was kind of a bit of an intriguing leap forward. And I think this is a very applicable quote, that any application that can be written in JavaScript will eventually be written in JavaScript. So this is Atwood's law, which is related to the principle of least power, I think they call it, which is this idea that you don't pick the most complex or the most powerful tools, you pick the least powerful. And I think this is pretty interesting because now, you know, you have the ability, I think, with the Web Audio API to create music in the browser, and where you'll never, certainly, I mean, I wouldn't suggest that you'll be able to create a digital audio workstation in a browser. You'll certainly be able to do synthesis and things like that. So I think that's intriguing, and that's what I'm pretty interested in. So let's talk about it. It's more than just the audio tag, which is pretty awesome as well. Very welcome. HTML5 audio is the subject of the HTML spec in investigating audio input playback synthesis as well as speech to text in the browser. So it's pretty kind of lofty kind of set of requirements there. If you look at the kind of use, you'll see that it's not very well supported. I mean, it's super experimental stuff at the moment or whatever, but all the major browsers begin to come on board. I think Chrome version 34 is the current version, I think. And it's finally dropped the WebKit prefix or whatever. So that's pretty cool. Okay, so if you want to know any more information about it, basically, there's a whole massive document there that's been kind of updated periodically. And it's fairly incomplete, but it's interesting reading, depending on your idea what's interesting. So let's talk very quickly about some of the features, okay? So there's tons of features, and I'm just going to fly through these. You have modular routing for complex mixing effects, such and so on and so forth. Sample accurate scheduled sound playback with low latency for musical applications. Automation of audio parameters for envelopes, fade-ins, fade-outs, yada yada. Flexible handling of channels in an audio stream, allowing them to be split and merged. Processing of audio sources from audio and video media elements. Live audio input, media streams, all that kind of stuff. Integration with WebRTC, which is real-time communications. Audio stream synthesis and processing directly in JavaScript. Spatialized audio, so you can kind of do all kinds of things like panning and all that kind of stuff. Convolution engine, which is basically kind of doing reverbs and kind of all that kind of other stuff. Dynamics compression, which is kind of an important component of audio taming, and real-time domain and frequency analysis, music visualizer support, and filters, other common stuff like that. Wave shaping for distortion effects, oscillators. So that's an absolute ton of stuff, but we'll only talk about kind of modular routing and a few other things like that. I'm kind of interested in the oscillators myself. So modular routing is kind of the basis of like the Web Audio API at the moment, which is this kind of idea that modular routing allows arbitrary connections between different audio node objects. Each node can have inputs and or outputs. A source node has no inputs and a single output, and a destination node has one input and no outputs. So that sounds a bit, I don't know, abstract, but basically that's all it is. You have something like a CD player, a record player, a synthesizer going into an amp, and then going into speakers. These are all nodes, basically. And the whole kind of concept of creating these kind of audio with this web API is you create these audio graphs, they call them basically. So you join up nodes, you just connect them all together. Okay, so let's look at some nodes. Am I doing okay for time? Yeah. Yeah. Okay, so the first one is the audio context, and it represents a set of audio node objects and their connections. It allows for arbitrary routing of signals to the audio destination node, where what the user ultimately hears. So basically what the audio context is, it's kind of like this kind of, I suppose, God object or something in a way. Basically you create an audio context for one document, and this becomes then the basis of how you create kind of all your other nodes or whatever. So nodes are created from the context and are then connected together. So here's some examples. You create a new audio context. I'm going to call that context. You want to create an oscillator. You basically have this kind of factory style methods for oscillators, for gain nodes, filters, and buffer sources, which is for playing back samples basically. So you use like the context and these kind of factory type filters or methods to create these objects. Okay, so let's look at a few. The audio buffer source node represents an audio source from an in-memory audio asset in an audio buffer. It is useful for playing short audio assets which require a high degree of scheduling flexibility. So these are kind of used to play samples basically. If you go onto the working draft, they have a kind of they show you the interface here. So you can do things like set playback rate, set loop points, and then kind of like set start and finish times and all that kind of stuff. So you can play a WAV file like this. I have an example of this. I'm just going to show the code first. You can all see that, yeah? So let's say we want to load a file, this WAV file basically, kind of like via an AJAX kind of request or whatever. So we create a context, and this is all just kind of loading in the file. You need to use the array buffer response type. This is kind of, it's going to load it in as kind of a binary data or whatever. So in this particular example, we're just going to trigger this callback on load. Basically when the WAV file is loaded in, we're going to decode it using this this method here, and that's going to call this callback here. So what you get basically, first of all, is you have an audio buffer, which is representative of the actual binary kind of data itself. You have to create a buffer source, which is going to be the node that is going to play the sample or whatever. We do some kind of connecting here. I'll explain a bit more about how you connect things in a second or whatever. This is just a kind of quick example. So what we're doing basically is we have our data and we have our kind of data player, I suppose, and we're just kind of we're assigning the data to the player or whatever. So source, you could probably look at that as, call that variable sample. Maybe it might be a bit more self-explanatory. But anyway, you can loop the sample, you can set loop points and endpoints, playback rate, and finally you start. That argument 0 just means start immediately. Okay, so let's have a kind of let's have a quick listen to that. Hopefully my local JSpin is going to work. So first of all, we'll go down here and I'll just kind of play this drum beat. Thanks to Colin for sourcing this, by the way. So it's pretty straightforward, you know. You can and you can kind of play with this kind of stuff then as you go along. What I'm actually doing is, let me just turn this down a tiny bit. What I'm actually doing is I started playing from the beginning, and now the loop end is basically the end of the sample, and the loop start is actually halfway in. So played from the start, went to the end, and then jumped back to halfway. So you can do all that kind of pretty cool kind of stuff or whatever. Now, if we start messing with this, you can start bringing up the volume a bit, you know. Or you get like really crazy and kind of I don't know if anyone's seen that, like Justin Bieber songs slow down 1,000 times, like, you know, but you can kind of get that thing going on or whatever, you know. So, okay, we won't kind of delay with this too much longer. Trying to see now if there's something else I want to, let's see. So I'll just give a very quick example of how you can do kind of looping. So as you can see now, we're only playing the first half of the sample. First quarter of the sample. You start doing your Fatboy Slim impression then, like, you know. If you really wanted to, which most people probably wouldn't. Anyway, okay, so that's one fairly kind of basic example. Then I had another example that I was just messing around with, which is kind of similar, basically. This is just another page I have on my machine. It's just like an object literal or whatever. Well, it's just some JSON, basically, representing a kind of a key map that I created or whatever, where I'm loading in these samples or whatever, and I'm actually mapping them to keys on the keyboard or on the computer here. So you can do like your Whitney Houston impression, you know that song, I Want to Dance with Somebody. It's like, so yeah, that was like the TR-808 or whatever, like, which is a pretty cool machine or whatever. So code for that is basically here or whatever. I won't dwell on it really. It's kind of similar to the example I showed already. You kind of, it's a bit neater because I decided to kind of make it a bit more reusable or whatever, but, you know, just basically kind of a loader object that loads in all these files or whatever and creates kind of audio buffer objects out of them, and then just to kind of do some mapping basically then. So we won't dwell on that anyway, because there's probably plenty of other stuff to look at. Okay, so that's the kind of sampling kind of side of things or whatever. So obviously you can play any kind of sounds you want, any kind of sample you want, and then kind of manipulate it and stuff like that. The next thing that I'm particularly interested in is the Oscillator Node, which is basically for creating kind of like, I suppose, kind of fundamental kind of frequencies like sines, squares, triangles, sawtooths, or whatever. So these are like basic waveforms or whatever. Or you can create custom waveforms if you want. And these are very, very basic building blocks of kind of like synthesis or whatever. So the Oscillator Node is kind of fairly straightforward as well. It has a few different things. It has audio params for frequency and detune. Now, an audio param I'll talk about a bit more in a minute, basically. Okay, yeah, I'll fly through it. So, okay, so you can basically change the frequency, you can change the oscillator type, you can start, stop. You can start to see that its interface is some way similar to the audio buffer node or whatever. Okay, so basic synthesis, you can just make the most basic kind of audio graph you can make is you can plug in an oscillator to your destination or whatever. Now the audio destination node is basically a fancy way of saying your speakers or whatever, and it's available as context dot destination once you create a context. Okay, so basic synthesis, we'll run through it here. You create our context, we create our oscillator, we connect our oscillator to our destination. So this is an important component, a part of the whole process where you wire up different bits and bobs or whatever. Then you create your type. I wrote sine in there, but actually you're supposed to do oscillator dot sine, kind of like it's a constant. You can set your frequency value, and then you can start and stop. So we'll have a quick listen to what that's like. This isn't going to be that exciting because it's just a sine wave. And it starts and it stops after 2 seconds or whatever. So you can obviously then change all this stuff. You can do, you know, let's see now. So you can basically change different waveforms and stuff. So that's pretty boring. But it's useful, obviously. It's kind of a building block or whatever. Now, again, you can create like your own kind of periodic waves. This is just another way of creating kind of a bunch of data, basically, to create a kind of your custom waveform or whatever. Now, what I'm just doing very quickly here is creating a really crappy methods to just create a load of ones and zeros or whatever in these kind of arrays or whatever. You create this wave and then you just feed it to your oscillator or whatever. So it'll create something random every time I play this. So you can see that the kind of the harmonic makeup of that is kind of different. So you know, if you ever need to create customized waveforms, you can do that. All right, so the gain node is the next thing, and obviously.
Sorry, Dara, just 2 seconds. Can you play multiple sounds at the same time?
Oh yes, of course. Yeah. You can. Yeah, I mean, like you can basically you can schedule like sounds or whatever. Like what for these examples now, for instance, we're doing. Yeah. For this example, you're kind of doing oscillator.start 0. But actually, there's an object, or there's a property of context, which is current time. So you can say context current time plus 2 for seconds or whatever. Like so, and you probably want to do that if you're doing like I'm working on a kind of a drum machine thing at the moment that's very kind of early or whatever. And the whole idea is like and the example I've seen so far is you see people kind of you know, taking a kind of a slice of an array and then kind of looping over it and then firing off things, where really you want to be pre-calculating that stuff probably if you want it to be kind of more accurate or whatever, you know. Oh yeah, cool, okay. So 1 minute? Yeah, 1 minute. Yeah, okay. All right, so gain node, we'll go through that really quickly again. That's basically volume. Okay, we'll move on from that. Audio params, I wanted to talk about this because it's kind of where you can start getting very, very interesting, basically. Audio params are where you can actually feed in like other inputs to kind of like dynamically change the nature of things like frequencies and all that kind of stuff. And you can do things like amplitude modulation, which is a type of sound where the frequency of one oscillator will affects the amplitude or the volume basically of the other one, and that's basically like tremolo when it's really slow. But when you speed that up, you get these sideband frequencies, which is kind of crazy. So you can get this kind of. No, you have that kind of tremolo effect, but if you go up. So yeah. I love that stuff. But that sounds pretty nasty, like, so you can actually you can use it to do kind of more musical stuff as well. So this is kind of a more of a, I don't know, evil bass. So yeah, Jesus, that was louder than I thought. Your frequency modulation, FM is kind of same kind of buzz, except you're using the frequency of one oscillator to affect the frequency of another oscillator as opposed to the amplitude. There's some information on that. FM is basically, you can make ambulance noises. If we ramp this up a mile, you can get kind of more interesting kind of noises or whatever. So the whole idea of these things is, you know, creating kind of more complex kind of sounds or whatever. So, oh yeah, I have to run this. So you can have fun where you can, oh yeah. Oh. And so on. Okay, I'm nearly finished, I promise. This is kind of the last one. So you have the filter node, which is basically low end, kind of like basic filters for sound or whatever. And I think this is probably going to be self-explanatory to everyone. I have all these different types here. We won't dwell on that either. But here's an example of whatever where we have, I think we have a square wave, and we're going to just, you can obviously filter that out or whatever. Can affect the Q, which is resonance and all that kind of stuff. So anyone who's kind of into analog synthesizers and stuff like that, you can see straight away how you can kind of emulate. Thank you. There we go. I had no idea that was going to take 25 minutes, but yeah, if anyone wants to ask me anything, like it's fairly basic overview or whatever, as you can imagine, but it's interesting stuff, and I think you'll see people starting to make synthesizers and stuff online, and I think that's a good thing. So thank you very much. Yeah.